If you put 1 volt across a 100 ohm resistor, you're going to get about 10 milliamps of current flowing through the resistor. 1 volt divided by 100 ohms, you do the math in amps when you're using Ohm's law, is 0.01 amps right there. 0.01 amps times 1 volt is 0.01 watts. So it's not going to get terribly hot. Most resistors are quarter watt, rated for a maximum of 0.25 watts, but you should still limit it to about 0.125. Now, if you double the voltage, you'll get double the current. You're multiplying them together, so you'll have 4 times the wattage. Be careful with wattage, that goes up a lot faster. Putting 1 volt across a 220 ohm resistor is going to get you about 4.5 milliamps of current. When you do the Ohm's law math, make sure you use amps. So we got 1 volt divided by 220 ohms is 0.0045, continuing forever, amps of current. Round it off. And then that current 0.0045 amps times 1 volt is only 0.0045 watts. Most resistors are rated for a quarter watt, 0.25 watts. You should still stay below 0.125 watts, and we are well below that. Now, if you double the voltage, though, that will double the current, and then you'll have 4 times the wattage. So the wattage, the amount of heat that is generated, goes up really fast when you raise voltage, so be careful. Now, we got one of the simplest resistors here. If you put 1 volt across a 1000 ohm resistor, you'll get 1 milliamp of current. Pretty straightforward. When you do the math, make sure you do the current in amps. So we got 1 volt divided by 1000 ohms is 1/1000th of an amp, 0.001 amp right there. Then you take the current times the voltage, that gives you the wattage, how hot the resistor is going to get, only 0.001 watt, very low. But if you double the voltage, you'll double the current, and therefore you'll have 4 times the wattage. So heat builds up quickly when you start raising voltage, so be careful you don't raise it too fast. So now, when I need a fair amount of current, I have higher wattage resistors. I have a 5 ohm, 10 watt resistor, and if you put 1 volt across it, you're going to get about 200 milliamps of current flowing through it. Of course, when you do the Ohm's law math, make sure you do that in amps. So we got 1 volt divided by 5 ohms equals 0.2 amps right there. When it comes to wattage, 0.2 amps times 1 volt, it's 0.2 watts. Now, if we double the voltage, we will also get twice the current right there. Both of these will be doubled, therefore we'll have 4 times the wattage. So you got to be careful raising the voltage that you don't exceed the wattage rating. We got 10 watts there. You should still stay below 5. But in any case, remember, when voltage goes up, so does current. So you got to pay close attention. Wattage is going to go up a lot faster. Now, for circuits where I need a fair more amount of current, I also have 10 ohm, 10 watt resistors right there. Try to keep it below 5 watts though. But in case you put 1 volt across it, you got about 100 milliamps of current flowing through it. When you do the Ohm's law formula for it, which you should know how to do, it's 1 volt divided by 10 ohms equals 0.1 amps right there. Now you multiply them together, 0.1 amps times 1 volt is 0.1 watt. So not terribly hot, especially because it's a 10 watt resistor. It's going to be fairly cool. But remember, if you double the voltage, that will be twice the current flowing through there. And double means there's 4 times the wattage, 4 times the heat generation. So you got to be careful. Now, when I want quite a bit of current, I have 50 watt resistors right there. They're 6 ohms. And if you put 1 volt across them, you're going to get about 170 milliamps of current flowing through it. Of course, do the math, the Ohm's law math in amps. So we got 1 volt divided by 6 ohms equals 0.16 going on forever amps of current right there. Round it off. So we got 0.17 amps times 1 volt. It's only 0.17 watts. Very low for a 50 watt resistor, although I still try to stay below 25 watts with the 50 watt resistor. But in any case, again, if you increase the voltage, you're going to increase the current. So double the voltage will be double the current, which means you'll have 4 times the wattage. So always be careful increasing voltage that you don't increase it too fast. Wattage are going up a lot faster.